section, I'm going to explain the general idea of a t-test and the general formula of the t-test. I call these general and basic. I'm using these terms because you will see throughout the next dozen or so videos that there are specific variants of a t-test that are all a little bit different from each other based on different assumptions, different things that you're testing, but all of the t-tests have they have this same fundamental architecture, this kind of skeleton that they all look like. And that's the general formula that I'm going to illustrate to you. So I'll also show you how to derive a p-value. And towards the end of this video, I will show you 3 different methods, 3 different ways to make sure that you are getting a large t-statistic when you actually have a real effect. So basically 3 ways of getting a significant result from your t-test. So let's begin. The main idea of a t-test is to compare the values, typically the means, between 2 different groups. So that's our hypothesis, that the data in the blue group have a different mean from the data in the green group. So these guys as a group are different from these guys. That doesn't mean that each individual member needs to be different from each individual member. So we can take an example of heights of adult men and adult women. Now, in general, adult men are taller than adult women, but that doesn't mean that every single man is going to be taller than every single woman. Of course, there are plenty of women who are taller than plenty of men. So the idea of the t-test is to determine whether as a group, this group has a larger mean or a mean that is different from the mean of this group. So that's the alternative hypothesis. We can contrast that with the null hypothesis of a t-test, which says that the means of the 2 groups are equal. And that would mean that basically we could, shuffle around the group assignment and it wouldn't really significantly change the means a lot. This random shuffling of data values into different group assignments is also the basis for permutation testing for t-tests. And I'll get to that at the end of this section. So I'm describing this here as if it were 2 groups. So we're testing this group against this group. It's also possible to test this group against, well, nothing. Then implicitly we're testing against 0. So we imagine that this group has a mean value of 0. And this group, we test whether the mean here is significantly different from 0. Obviously, that doesn't make sense in the case of height. But you can imagine a situation where, we're testing whether some particular medication, maybe it's a new vitamin, let's say, a new vitamin makes people feel happier with their life. So they take a new vitamin and then we see whether the effect that that vitamin has is different from 0. Okay, so this is the basic idea of the t-test. We are testing one group against another or one group against a value of 0. And here is the general formula for the t-test. So I encourage you to write this down or commit this to memory. Somehow remember this t-test formula. As I mentioned in the very beginning of this video, not every single formula for all the variants of a t-test will look exactly like this, but they will all look kind of like this. So once you have this template formula memorized, it's going to be really easy to learn all of the other variants of a t-test. So what are these terms here? So this is X bar and Y bar. This is the average of group 1 and the average of group 2. And this is S, this is the standard deviation, the sample standard deviation, divided by the square root of N. So N is the number of samples, S is the standard deviation. Again, the precise details of exactly how this formula looks will differ, and you will see throughout this section different variants of this formula, but they all look kind of like this. Okay, and the way to think about this formula, you can memorize some letters and horizontal lines and things like that, but the way to think about this formula and the way to internalize what a t-test is really measuring is the difference of means divided by standard deviations. And that's the general way to think about that. So a difference of the means divided by or scaled by, we could say normalized by the standard deviation. Okay, the difference of means divided by, okay, and the way to think about this formula, you can memorize some letters and horizontal lines and things like that, but the way to think about this formula and the way to internalize what a t-test is really measuring is the difference of means divided by standard deviations. And that's the general way to think about that. So a difference of the means is the standard deviation. Again, the precise details of exactly how this formula looks will differ, and you will see throughout this section different variants of this formula, but they all look kind of like this. Okay, and the way to think about this formula, you can memorize some letters and horizontal lines and things like that, but the way to think about this formula and the way to internalize what a t-test is really measuring is the difference of means divided by standard deviations. And that's the general way to think about that. So a difference of the means divided by, or scaled by, we could say normalized by, the standard deviation. Okay, so because of sampling variability, there's going to be a range of t-values that you could expect even if the null hypothesis were true. So that's what we have here, the probability of a certain t-value occurring given that the null hypothesis is true. So if the null hypothesis is true, then we say the difference of the means for the two groups is 0. We would expect this to be 0. So the expectation value of the t statistic under the null hypothesis is 0. But of course, there's sampling variability, there's noise, there's all sorts of things that will push the t-value around a little bit. So therefore, this is the distribution of t-values that we can expect under the null hypothesis. And then the idea of determining statistical significance and deriving a p-value from a t-value is to compare the t-value that you